Hello, my name is Brinley Davis, and I'm in the 8th grade of Friends Academy. My experiment is called How Can We Make the Biofuel Production Process More Cost-Effective? I'll split my video into 3 parts. 1, about the experiment, 2, my results and conclusion, and 3, how is my experiment relevant to the real world? 1. My hypothesis is if the extraction process of biofuel from algae methods improve, then I believe that algae will prove to be a cost-effective and efficient source of biofuel for the 21st century, because algae is so abundant. The lipid extraction process. Phospholipids are what make up cell walls. The oils extracted from these lipids is what is used to create biofuel. Today, the problem of extracting lipid oils has become a very complex and expensive process in biofuel production. My goal was to find a solution to the latter. When making biofuel, I blended the leaves with water to create a puree and centrifuged the liquid so all the lipid oil would rise to the top. I found this to be most efficient. Biofuel experiment. In order to create a successful biofuel, I had to play with different ratios and ingredients. At the beginning of this experiment, I was confident that algae would be the perfect plant to use for my biofuel. It had lots of lipids, was very abundant, and was being used by scientists and companies making biofuels all over the world. But the growing process of algae was unexpectedly difficult. After 3 failed attempts, I started to look for other plants that could possibly fulfill the criteria of my biofuel. I needed a plant that had lots of moisture, lipids, and was easy to grow or buy. I came across spinach. Spinach was perfect. It could easily buy fresh spinach at any store and was able to extract the lipids easily. Now that I found my plant, I could finally start creating my biofuel. I ended up using isopropyl alcohol and liquid lye to create a spinach biofuel that burned. When the amounts of these ingredients had to be perfect ratio in order for the biofuel to work. I tried many different quantities and settled on 1/4 cup of spinach by lipid oil, 3 tablespoons of 90% isopropyl alcohol, and 4 tablespoons of liquid lye. After finding quantities that worked, I then focused on my original goal, making the biofuel making process more efficient and less expensive. I started researching again and read about an enzyme called cellobiase. This led me to my next experiment. Cellobiase experiment. The cellobiase enzyme breaks down cell walls into simple sugars, making the lipid extraction process easier. My goal in this experiment was to figure out the maximum rate of cellulose produced in a certain amount of time. Fungi has a lot of cellobiase, so I chose to use mushrooms for my experiment. I would add cellobiase to the mushroom slurry and wait a precise amount of time for reactions to happen. Once time was up, I added a stop solution to stop reactions. This gave clear results as to how many reactions happen in a specific amount of time. I combined broken up mushroom cells with cellulose 5 times for different durations of time. I had 6 vials. After the stop solution was added, I processed each vial with the respective photometer for a quantity measurement of the reactions happening. Variables. Biodiesel experiment. The independent variable was the components of the methodology. Dependent variable was the quantity of biodiesel produced as indicated by the length of the burn. And the controls were the amount of spinach used and the extraction ingredients. Cellobiase experiment. The independent variable was the ratio of stop solutions to enzyme. The dependent variable was the rate of cellulose produced. And the controls were the amount of cellobiase enzyme, the times enzyme was exposed, and quantities of all substrates. 2. Biofuel experiment results and conclusions. After spending 2 years dedicated to finding the perfect ratio and recipe for biofuel, I finally was successful. The ingredients I conclude are the most efficient are spinach lipid oil, 95% isopropyl alcohol, and liquid lye. With the proper measurements, I successfully made a batch of fuel that, when touched with a match, burned for around 10 minutes. This batch was 3 cups of fuel. In comparison, 3 cups of diesel takes around 12 minutes to burn, making biofuel very close to being as efficient as diesel. This is a big success. Cellobiase experiment results and conclusion. After mixing cellobiase with mushroom cells, the reaction rate results were shown in 2 ways. One being the color of the liquid after stop solution was added. The darker the color, the more reactions occurred. Second, the amount of light able to pass through the vial from the spectrophotometer. Overall, these results show that the rate of reaction was higher when the time for reaction was higher, as expected. With this evidence, if more cellulose was added to spinach when extracting lipids, this process would be more efficient. This resolves the question of whether we can make lipid extraction process more productive. 3. How is my experiment relevant to the real world? Climate change. In today's world, climate change is the number 1 issue. Pollution of the air, oceans, and land have caused major environmental destruction. The highest cause of climate change right now is greenhouse gases. These gases are destroying the Earth's atmosphere and are heating up our planet. The diesel used to power cars produces lots of greenhouse gases when it is burned. There are few current solutions to the fossil fuel problem regarding diesel, like electric cars and solar power cars. But these resolutions are expensive and will take a very long time for people to adjust. Biofuel doesn't give off greenhouse gases and is not made from fossil fuels, so our supply is not limited. Using biofuel also won't require adjustments for current routine, like gas stations, cars, and fuel engines, etc.